In this video, we are looking at how FastAPI applications handle configuration, things like database URLs, API keys, and feature flags. We will use Pydantic's base settings to load those values from environment variables, validate them automatically, and inject them into your root handlers without scattering hard-coded values or secrets through your source code. Here is the situation most developers hit first. You need a database URL in one file, an API key in another, and a debug flag somewhere else. You call OS_get_env in each spot, maybe with a fallback, maybe without. A missing variable does not blow up until the request that actually needs it, which might be in production. And because the values live in scattered strings, there is no list anywhere of what the app actually requires to run. Think of a pilot's pre-flight checklist. Every required item, fuel level, tire pressure, radio frequency, is verified before the plane leaves the ground, not discovered missing at 30,000 feet. Base settings works exactly the same way. It collects all your configuration requirements in one place and validates them at startup, so you get a clear error message immediately, rather than a mysterious crash inside a live request handler. There are 4 moving parts. First, you define a class that inherits from base settings. Each field is a type-hinted attribute, and Pydantic reads matching environment variables by name automatically. Second, you write a plain function called get_settings that instantiates that class. Third, you decorate it with LRU_cache, so the environment is only read once per process. Fourth, you pass get_settings to FastAPI's depends, so any root can receive a validated settings object without importing a global. Let us walk through this file top to bottom. The settings class extends base settings. Each field is type hinted. App_name is a string with a default. Database_URL uses Pydantic's any URL type, which validates that the value is a real URL. Debug is a bool, and max_connections is an int. The inner config class tells Pydantic to also look for values in a .env file. The get_settings function simply returns a new settings instance, and the LRU_cache decorator means that function body runs exactly once, caching the result for the lifetime of the process. Down in the root, we declare settings as a parameter type to settings and wrapped in depends of get_settings. FastAPI calls get_settings, gets the cached object, and passes it into read_info. The handler then reads fields of it just like a plain Python object. When the first request arrives, FastAPI's dependency system calls get_settings. Because LRU_cache wraps it, Python checks whether the function has been called before. On the very first call, it runs the body constructing a settings instance, which causes Pydantic to read every matching environment variable and validate the types. If database URL is missing or debug is set to something that cannot become a boolean, you get a clear validation error immediately. Every subsequent call returns the cached instance in microseconds, so there is no repeated I/O and no performance penalty for injecting settings into many routes. Use base settings with a cache dependency when your application has any sensitive values, when it runs in multiple environments, or when you want a contract that makes missing config a startup error rather than a runtime surprise. Consider skipping it for tiny scripts or completely static configuration that never varies. Also note the one real trade-off. Because get_settings is cached, overriding it in tests requires you to explicitly clear the cache or use FastAPI's dependency override mechanism, something to plan for from the start. To recap, base settings centralizes all your configuration in one class and validates every value the moment the app starts, so bad config fails loudly and early. Type hints do the coercion work for you. A string in the environment becomes a proper boolean or URL in your code. The LRU_cache plus depends pattern gives you a single lazily built, shared instance with no globals. And because values come from the environment, your secrets never have to touch your repository.